we're going to talk about the double angle identities. So here, we're going to show how we obtain the double angle identities for sine, cosine, and tangent. And actually, to do so, we're going to use our our sum identity here. Now, this is sine of 2x, which makes it a double angle because it's 2 times the angle. Yeah, you guys are right. We do try to make things harder for you. Yeah, this is a double angle, sine of 2x, which we can write as sine of x plus x. So let's talk about how we could figure out what the double angle identity is. Well, this, I can use my sum identity. So that's going to be sine of x times cosine of x plus cosine of x times sine of x. Oops. But that's just 2 sine of x cosine of x. It's actually our double angle identity right there. Okay, so these are related. This is the identity here, that sine of 2x is 2 sine of x cosine of x. Again, we have a double angle. I just want to remind us that this does work in any situation. For example, let's say I had sine of 6x. Okay, well, that's equal to 2 times the sine of 3x cosine of 3x. Okay, so this angle is double this angle here. Okay, so it does work in any situation as such. Okay, let's have you guys figure out what the double angle identity is for this one. Now, just as a forewarning, there's actually 3 different ways we could potentially write this identity. So let's see if you can at least come up with one of them. Okay, so go ahead, put me on pause. Let's see if you can do it on your own. All right, like I said, we get 3 potential identities. So the cosine of 2x, so the double angle identity for cosine, you could have cosine squared of x minus sine squared of x, which can be rewritten as 2 cosine squared of x minus 1 if we're using that Pythagorean identity, or that's also the same thing as 1 minus 2 sine squared of x. So any 3 of these would work. You might find situations when one might be more useful than the other. So it is nice to know your options there. Next one, let's have you guys do this one as well. So go ahead and put me on pause. Okay, nothing crazy for this one. So we get tangent of x plus tangent of x all over 1 minus tangent squared of x. So simplify, that's 2 tangent of x over 1 minus tangent squared of x. So that's our double angle identity for tangent. So let's put this to use. Let's try a problem with this. So we have solve. It wants us to actually find a value for a. And notice that it didn't give us any restriction on our answers, so this should be a general solution. Okay, so let's see what you guys can do. Notice here I have sine of 2a, so you'll probably want to use your double angle identity. I mean, that's what the title of the notes are. So, okay, go ahead, try it, put me on pause. All right, so I use the double angle identity here to rewrite sine of 2a as 2 sine of a cosine of a. Still times sine of a. Then we know that we're not going to divide both sides by cosine of a because that would be bad. So we're going to actually subtract it to both sides and set equal to 0. Now I can take out a GCF of cosine of a, and using my zero product property, I can solve for a. So in this case, I got a is pi halves plus pi n. Again, we want to find our general solutions. And I also find that a is pi fourths plus pi halves n. All right, so in conclusion, just make sure we understand how to develop and use the double angle identity. So even if it's not something that you memorize, even though I hate that word, it's always something that we can derive on our own, just knowing our sum and difference identities.